Welcome to the 14 megawatt schematic room. In this space, we'll be going over how this wind turbine produces power. Check out your syllabus to see our agenda. As a start, let's get a good look at how large the wind turbine really is. The 14 megawatt wind turbine is over 850 feet tall. First, we'll be going over the hub and blades. The 14 megawatt is a 3-bladed wind turbine. The large blades combined with the powerful rotor maximizes the capture of energy. As we travel around the room, we will talk about each piece of the turbine and get a better idea of how it ticks. The hub supports the rotor blades and houses their pitch assembly. It is designed in a way to provide quick access to technicians working from the nacelle. This is the pitch system. The pitch system regulates the power output of the wind turbine by adjusting the rotor blades. It also functions as the main brake. Now we know the basics of how power is generated from the turbine. Next, we'll be going over how the generator and yaw systems work. The generator is a key component of the turbine, because it is the component in charge of generating electricity. As the blades of the turbine rotate, raw power is created by the generator. This is the yaw system. The yaw system is responsible for the orientation of the wind turbine rotor towards the wind. The yaw system is made by the junction of a bearing and crown, moved by the yaw motors shown here. Let's move forward to see how power travels through the system. We're going to be going over the electrical system of the turbine. Power moves through the generator to the converters, then into the transformer. The electrical system converts the power and pushes it down towards the base. These cables usually run hundreds of feet from base to top, so we've shortened the trip for brevity. Finally, this is the base power transformer. You have successfully covered the anatomy of a turbine. Now that we've seen a dissected turbine, let's go inside one. Here we are at the base of the wind turbine. This is where electricity exits through the base power transformer. We'll be visualizing the flow of electricity through the turbine using this effect. When you are ready to visit the nacelle, teleport to the elevator to go up. Alright, that was a nice ride. There are two different types of cables used by the 14 megawatt electrical system. These are one kind of those cables. In particular, these cables move from the transformer to the switchgear. These cables have a very high voltage rating of 66 kilovolts and are installed with clamps. This cable loop allows torsion due to yawing of the nacelle. We're going to head up to the nacelle. Teleport over here to start climbing. Climb the ladder by gripping and pulling yourself up. I'll see you up top. You did it! Time to really see what makes this turbine spin. Contained here, there are a variety of electrical auxiliaries, cabinets, and cables that comprise the electrical system of the turbine. We're currently located inside of the yaw system. The yaw system makes it possible to rotate the nacelle to face the direction of the wind. Over here you can see the hub. This houses the blades. It's the part of the turbine that spins. That is the transformer. Teleport over to it. The transformer has an input voltage of 3.3 to 6.6 kilovolts. However, the output voltage is 66 kilovolts. This transformer weighs around 30 tons. Whoa! This is one of the powerhouses of the nacelle. The above two help too. Let's go upstairs. The stairs are over here. Here we see the generator, where energy production begins. Here we can find the other type of cables used by the electrical system. These cables have a 3.3 to a 6.6 voltage range. They are configured in a trefoil arrangement, and they are installed using cable ladders. To the right, we see our converters. These are responsible for converting power from the generator for the transformer below us. The converters are capable of running at full power at a voltage range of 3.3 to 6.6 kilovolts. They can work with either 1, 2, or 3-phase systems, and weigh about 10 tons each. We've explored the 14 megawatt turbine interior. Now let's go to the roof. Teleport to the base of the stairs. Well done. We're ready to apply what we learned. Teleport to the roof when you are ready. Welcome to the roof. We're going to spend some time seeing how different conditions affect the turbine's generation of power. First, I'll teach you a bit about each of the variables in this equation. These panels represent the different values of the wind energy equation. This panel represents the wind energy output. In simpler terms, this is how much power the turbine is generating. Here we have the air density. This will affect the total output along with the wind speed. Speaking of the wind speed, this is that. The faster the wind flows, the faster our turbine blades can spin. Finally, we have the airflow area. This is the total area the wind is flowing through. Primarily, we calculate this by a turbine blade length. You'll be interacting with these panels in order to alter values in the equation and produce optimal amounts of power. Before we start playing around with these values, we're going to elevate ourselves a little to get a better view. Alright, I can practically feel the cold air on my facial display. Time to start playing around with our variables. In order to change the value of one of these pins, bring your controller forward and try to move the slider with your stylus. Try changing the airflow area now. Notice the length of the blades change as you alter the airflow area panel. The 14 megawatt turbine has a blade length of 110 meters. Try bringing the blade length to 110 meters and see how this affects the power output. Whoa, those are some pretty long blades. Check out the energy output panel to see how much power we're generating. Just for now, I'll be setting the wind speed. Then I'll let you take full control. What you just noticed was the cut-in range of the turbine. When the wind is below 3 meters a second, the wind turbine doesn't generate power. There is also a cut-off speed limit. I'm going to ask you to bring the turbine to maximum power generation by playing around with these values. There is a rated speed you are trying to reach, in addition to the blade length I provided beforehand. Good luck and have fun on this next assessment. Try maximizing the energy output of the turbine, but be mindful of the turbine safeguards. Try maximizing the energy output of the turbine, but be mindful of the turbine safeguards. Air density is determined by the pressure and temperature of the air. We're visualizing this by the amount of wind particles around us. You've entered the cutoff area, or around 31 meters per second wind speed. This happens as a safeguard, as the higher speeds may expose danger and seriously damage the turbine. Try bringing the wind speed back below 31 meters a second again. Congratulations! You've entered the rated speed range for the turbine. Notice how high the energy output is. The 14 megawatt turbine can generate more than 67 gigawatts per hour annually. Great job! You must be an expert on wind turbines by now. Feel free to play around with the variables as much as you'd like. We really hope you learned something today. Thanks for joining me. When you want to restart the module, teleport over onto the exit portal to start it all over again.